Okay, thank you everyone for waiting, and we're about to start. So this talk is going to be about Kong. This talk is going to be about Kong, about API make microservices in general, and how we can use Kong for enforcing some security upon them. But first, some kind of a short introduction about microservices in general. Then I'm gonna talk about API gateway architecture, and then we're gonna finish it off with how Kong fits into the entire picture. I'm gonna start off with a short overview of talking about microservices versus monolith applications. What are the pros about microservices? They are more lightweight. They have a reduced range of responsibility for each microservice. So yeah, again, a little more lightweight. And if done properly, this is why I put this asterisk down here. If done properly, there is hopefully a reduced risk or scope of a failure in case of something fails. Which I'm going to talk about in a minute. And yeah, the microservices should be, in general, easier to scale versus monolith applications. The cons being there is obviously more work to expose and document API endpoints, because not everything is anymore tightly coupled into one big system. There is no programmatic interface. There is an API interface between the services. So this means obviously more communication overhead, because those services, if they need to communicate, and there's a big chance that they do, this all depends upon your setup about the entire system. It's individual from situation to situation. And obviously, if there is some inter-service dependencies, example, one microservice depends on another microservice, then again, there's more planning involved. Which service needs to know what and why and how it should be communicated between the services. And again, and finally, there's more deployment overhead. By deployment overhead, I'm being a bit ambiguous, but obviously, you're no longer deploying one giant system. You're deploying 2, 3, 5, whatever number of systems that you have split this monolith system into microservice. So each service obviously needs its own development and deployment lifecycle, and so on and so forth. If we have a look at this diagram, this would show how these services would look like. Here we have on the left side one monolith service that has consisted of multiple services. For example, this is just for reference sake, but for example, we have some security, we have some business services, we have some authentication, perhaps some static content, some cache and database. And well, in this very simplified view, if we split it up into microservices, each of these services would start living its own life as a standalone system. This purple-ish, if this is a purple, I'm a bit colorblind, or at the very least I don't know which color is named, but in this colored background, you can imagine that this is an actual server or a droplet or whatever container it is that you're running your software on. So the first obvious difference here is you can see that these services can be run on multiple computers. Each computer or a server can do its own microservice. If you want to scale a monolith server or a service, it would be like a vertical scaling. Vertical scaling meaning that you would simply expand your server's resources, add extra CPUs, add extra RAM, and so on and so forth, so you would get a bigger server. The other option is to have a horizontal scaling where you would just instantiate another instance of that server, and that would be identical to the first one, and put a load balancer in front of it. Again, please note that this is a very simplified version. Obviously, you would not replicate databases in this fashion, or it would need much more work to be done. By contrast, if you have a microservice architecture, you could scale it like this. Again, a vertical scaling. Each microservice would be scaled depending on the needs. So again, we could just increase RAM or CPU power or whatever. And regarding the horizontal scaling, we could just instantiate lots of instances of these services and put a load balancer in front of those. This slide might already give you a brief intro or a sneak peek. Why would we want a gateway in front of it? As you can see here in our example, there is a lot of microservices that are now just floating around in space, and there is no big organization to it, meaning that, for example, if all of these services are exposed to the outside world, somebody could access the business service one and do some queries, or, for example, if it's an e-commerce, delete a price, whatever, which we don't want to do. So these security and authentication services are dislocated and basically not really doing anything to protect the business services. So why do we want an API gateway? To unburden the microservices of the responsibility of having their own authentication and authorization methods, meaning that if we would want to do this, each of these services would need to have its own authorization and authentication and security mechanisms, which would be a lot of overhead again, and would be effectively a step back to monolith architecture. So authentication, security, SSL termination, and lots of other aspects which may be out of the scope of this topic for now. So let's just focus on the authentication and security. If we were to introduce API gateway architecture, it would look like something like this. So these are the services a bit rearranged, but still essentially the same thing that we're doing. API gateway being in front of all of these services. This little cloud is the internet. API gateway would be the first and the first line of defense to stop anyone from querying any kind of business service that he might not want to be allowed to. There we would have some kind of authentication or identity management system that would tell API gateway who is allowed to access the microservice, who is not, and the API gateway would, based on these credentials, just allow REST requests, for example, to pass or do not pass.
Would this architecture mean that the API gateway is dependent upon the authorization microservice?
Yeah, if you want to have authentication, yes.
Okay.
So it is, as you will see later on, Kong has a lot of features, but one of them is not identity management. It relies on an external service to provide identity manager, whereas it has a lot of other features that can enforce the identity management and authentication towards the microservices. So this is the thing. Few short notes about Kong. Kong is built on top of Nginx, which is a file server, reverse proxy. It has a lot of applications, and it is very extendable and fairly lightweight. Kong actually, so you can imagine it as a standard web server on steroids, meaning that Nginx functionalities, all of the functionalities that we're going to talk about are already available via plugins or via custom configuration, but Kong is that layer on top of Nginx that exposes those functionalities via REST service. So it is, again, more easier to manage these functionalities. So it provides REST API endpoints for managing all of its features, and few buzzwords that you would want to know about Kong at the very top is as follows. So service is a upstream. It is something that defines an upstream service that Kong will route your or forward your request to. So basically, in this notation, so this would be a service. The route is obviously something that we can hook onto a service, so we can definitely specify which query string routes are corresponding to each service, and vice versa. And finally, the consumer is a person that consumes that service. So, mind you, that doesn't need to be a person. It can be, it's intentionally named very generic. So, consumer can be a person or another service or anything that wants to connect to your service. So it would look like this. Somebody from the internet wants to access /cart route. API Gateway knows that the /cart routes are belonging to this particular service, and so on and so forth, and also for the profile and so on. Again, this is a very simplified way of looking at things. What we're gonna do, what I'm gonna show you right now is to quickly set up Kong by using Docker. We will run and provision a Cassandra database, which Kong is relying on to save its own settings. We will run Kong. And Konga, which is an open source Kong admin UI, and we will create some test and sample service route to show how everything works then. A few words about available authentication options. These are currently available in Kong basic auth, so that will be the most basic one, the API key being some query string or header that you can put into your requests, a JVT, OAuth2, HMAC, and LDAP authentication. For the purpose of this demonstration, I will be showing the API key and the JVT. So let's then go to the console. I have my little cheat sheet here. We have a very empty Docker-enabled VPS running. First of all, we're going to create Kong network, which is a virtual Docker network that all of these components will be using. Cassandra image or Cassandra database engine will be using this network. Let's go ahead and instantiate that one. By the way, a few words about Cassandra, or in general, how Kong uses its database. Cassandra is the default database that Kong likes to use for many reasons, one of which is that Cassandra is fairly easy to replicate, so it has its own mechanisms to persist data across multiple instances which are connected to a cluster. so it has a lot of potential for high availability. Secondly, Kong will ping this database or write to this database, obviously, only if there is some change onto the route or service setup that we're making. And it is pinging the Cassandra database every, I think 5 minutes is default, just to see if some other instance of Kong or somebody else, if you have a cluster configuration, has made a change into the configuration itself. I'm intentionally giving myself enough time before hitting another command, because Cassandra takes a few moments to load. So hopefully, if I do this right now, everything will be okay. Otherwise, we will get information that Cassandra is not yet running. But since it is bootstrapping now, it feels okay. So the other command is now instantiate a Kong expandable Docker image, which will only do initial connection to the Cassandra and do the database setup. So it will basically preload and all of the schema and set everything up for our usage. Also, as I just realized, I also executed another command, which is to actually, oh no, I haven't, it's still in the buffer. Okay, so the Cassandra is now up and running and provisioned. All of the tables have been created. We can now go ahead and run this command to set up Kong as a daemon process. Again, it is connected to KongNet, so this is an internal network here, but we are exposing all of its ports to the outside world. So by default, ports 8000, we're mapping it to port 80, a standard HTTP port. 8433 for towards 433, that's the SSL port. 8001 is the default port for admin interface. And we're obviously using the latest release of Kong, which is currently Kong version 1.0. Okay, now this is running, apparently. As we can see here, let's do a quick test. And there we go. Sure enough, we got some response from the admin API interface. Very important, again, to be aware of. This is not a very secure environment, so this is extremely bad right now because Kong's admin port has been exposed to the outside world, meaning that anyone can tamper with it. Okay. And finally, because I'm lazy and I don't want to give myself chance to miswrite any command rest call while typing it manually, I'm going to use Konga image, which is a Node.js based web UI for Kong, which will basically give us a very nice eye candy view of Kong itself or its administration. By default, it's listening on port 1337. So let's see if it will fire up. Okay, by default it will again declare to the outside world, hey, okay, you must be the admin, so why don't you go ahead and register yourself and we will give you admin rights. Don't do this in production. And something went wrong because it can. This is probably because I already created 10,000 variants of this service, and somewhere in the buffer or cache we had a previous connection. So yeah, this is the Konga dashboard. So there are a few eye candy statistics here about the active connections and so on and so forth. Let's go ahead and create our own service. For the purpose of this demonstration, I'm gonna do a mockbin service, which is a cool little lightweight service, online service that will basically echo your request back to you. So it's perfect for this kind of example. Let's give it some tags. Let's give it some protocols. It will be on HTTP protocol. Mockbin.org, port 80, path, request. And these are the default values for API gateway, how much time the Kong will try to redo the request towards the origin server or the service until it gives up. So now that we have a service, we have defined where it is living, on which port it's listening, on which path it is by default listening. We can go ahead and create our own route. Let's call this route test. Just to be very explicit, let's say that we will react to this route only if it comes on this host name and on test path. Regex priority is something that you can have fun with in determining if there are multiple routes that have the same very similar configuration, which one should be taken into account first. By default, Kong is just going through all of the routes that you have defined by the time of creation, so it will just evaluate whichever route it comes by first. Let's keep the methods empty, and I think this should be enough. So by this, let me just give you a very short example. This is the mockbin service that I'm using. Let's open up the Postman here. If we go to mockbin like this.
Didn't you just copy it right now into your clipboard?
No.
Oh.
Mockbin.org, mockbin.com, yeah, okay. Okay, so this is the service that we're trying to get. This is some response that we are getting from it. And if we want to do it by using our own API gateway that we have just set up, we would be using this route here, docker1 node recall.com/test and some query parameters. Hopefully it will work still. Yes, it works. Okay. Now I'm getting all emotional, but yeah, it's no big deal. We have configured it that way. Yeah, so obviously it will work. Okay, so again, this doesn't look very spectacular, but let's do something fun with it, and let's say that we are only gonna allow this route to be accessed if there is somebody using some kind of a API key. So let's say API key. We want to listen for API key. We want to hide the credentials towards the upstream server. We don't want anonymous access, and let's run it in pre-flight, meaning that it will also run on options request. Right now, this route should be no longer available in to the outside world, as you can see here, because we have protected with the API key. How to enable our consumers to actually consume this service now is by going into the consumers and create some consumers. Let's say username is semi-optional, custom ID is semi-optional. Let's call this consumer mobile app, because let's assume that it is a mobile app that will be using it. And let's give it some credentials, an API key. Let's have it auto-generated. If you don't provide it to conk, it will auto-generate it. So coming back to our service, mogbin, and inspecting our route, we should be seeing a list of eligible consumers. And as we have configured it, anyone that carries this credential API key will be allowed to access this service. So if I'm not mistaken, this should be, again, locked. If we provided it by using a get parameter, did I use underscore?
I think so.
No, perhaps not. Let's see what that once again. Mobile app plugins, key authentication, key names. Well, I didn't do anything. Yeah, there we go. There. So if I do this as a query parameter, this now will be, of course, working because conk has recognized this from a query parameter. Conk will also look into the headers. So if you provide that credential as a header, this will also work. So you have this flexibility of deciding for yourself if you want this as a header or as a query parameter. And right now, this is a very simple setup. We have our own consumer. We have some API endpoint that we're routing, but conk supports also the ACL, meaning that you can have your own consumers. Let's create, let's see, desktop app. And let's give it also that API key credential, the same one. Whoops, it's unique. Okay. So now I'm embarrassed. But okay, let's give it another key. No matter, we can do this the other way. So ACL means that conk gives you ability to provide your consumers with any arbitrary group names, as you would in any other secured environment. So let's call this admin group, for example, and we can call this, was I now currently? Yes, I was. Let's call the mobile app mobile group. So for your route, you can also give very more fine-grained security setting, where by using the ACL plugin, you can whitelist specific users or groups that you want this service to be accessible to, other than just providing an API key. Let's say that only admin. Did I use admin or admins? Damn it. Okay, admin. Let's say that only admin users or consumers that have admin group are available. So again, here you can see in this eligible consumers part that this particular route will be accessible to all of the users that have this group and carry the credentials. By contrast, if I put this ACL and say that only, again, I forgot it. Did I use mobile?
Mobile underscore app.
If we do this, then obviously none of the currently available users will be eligible. We can prove that.
Shouldn't the mobile apps be eligible for this one?
Well, this is project specific then.
Yeah. I know, but didn't you create a user called mobile app?
And gave
Yes.
him the key.
Yeah, and gave him the API key.
But exactly. This is exactly why I did this, reversed this, because even though I have a consumer called mobile app, It belongs to mobile group.
Oh, it doesn't belong to admin.
It doesn't
Yeah.
belong to an admin group. That's why he doesn't get to consume this service.
Okay.
Okay, so this is pretty much it. What I wanted to show to you today, because obviously it has a lot of connecting points to what we're currently doing in our projects. The next step that comes into play is obviously the certificates. Kong has its own support for certificate, of course, because it's an Nginx. So you can handle certificates again through the REST API endpoints. There are a few cool Docker containers images that can consume this REST admin API for Kong and inject the SSL certificates for you, so you don't need to do this manually. This can be automated. And something that I might want to talk about again sometime later is the load balancing option that Kong also provides, but this is outside of the scope of this talk right now. Let me just see if there are no. That's pretty much what I wanted to show to you for today. There are some few cool links here to read. So building microservices using an API gateway, some general stuff about the API gateway pattern, obviously the Kong documentation, which is very actually nice. All of the installation, quick start, and the reference to the admin API are here. So all of the Kong REST API endpoints are very nicely documented. So basically you have the entire overview of how to manage a Kong without using some kind of a API UI. Which again is very beneficial for us as developers if you want to have some programmatic access to Kong to dynamically configure the routes. You can do that through the REST API. Okay, are there any questions, comments?
How old is this Kong since it's version 1.0? Relatively new.
It is relatively new. Mind you, there are quite a few releases before, but with 0 something. I don't have a very exact figure, but I think it's somewhere in the range of 1-2 years.
Is there some similar tool to this?
Not that I have found, a part of AVS, obviously.
Yeah.
Is it paid for?
This particular instance we're running is free, so there is a Kong and Kong Enterprise. We're using the community version.
Mm-hmm.
Kong Enterprise version gives you the admin UI, which you already have as an open source project, but it is more comprehensive. It has more eye candy diagrams, so on and so forth. It has some more features that you might want to have. Okay. Well, if there are no more questions, that's it for me. Thank you.